Okay, so hello everyone, welcome. So, can you hear me clearly?
Yes,
Okay, so I share my screen. Can you see my screen?
yes, yes,
Okay,
yes, your screen is visible.
okay. So, hi and welcome to the second day's training session on Google Earth Engine. And I am Mizan and I will be tutor for this course. So, basically, today is our second day and today our course content will be that first of all I will try to discuss how you can easily filtering and visualizing the satellite images in Google Earth Engine. So mainly in this here I will try to discuss how you can easily filter and visualizing the satellite images Landsat and Sentinel. Okay, and after this how you can easily display these images. Then how to export the satellite imagery as a TIFF format. Okay, then we will move to the analysis of the global precipitation measurement 3-hour dataset using Google Earth Engine platform. So mainly in this time I will try to discuss about the time series chart analysis. Okay, here I randomly take a dataset. This dataset is the global precipitation measurement 3-hour dataset, but this dataset is the same procedure for the all of this dataset. Okay, when you make the time series analysis, then I will try to discuss how you can easily calculate the NDWI from the MODIS and Landsat data using the Google Earth Engine platform. Then how to export the TIFF image and how to export the any shapefile from the Google Earth Engine platform. Okay, so basically I will try to discuss all of this course content. I will try to finish, and before starting this today's course content I will finish the rest of the previous the code. So this is the for the reprojected the scale value. Okay, so we already work this type. So here you can see, and tomorrow we will try to discuss how you can easily filter, then import, then how you can easily calculate the NDVI from the MODIS satellite data. And we already write this code for the calculated the MODIS NDVI. Okay, so here you can see, but we have faced a problem. This problem is that this NDVI value is not the reprojected. Okay, so it means that this value will not be between the -1 to +1. Okay, so that's why in this time I will try to show you that how you can easily make the reprojected the scale value. Okay, so if you want you can check it this scale value. I will try to show you that. So first of all I simply click on the inspector tab and click on the any portion on the map. I can get the this point specific value. Here you can see I can get the value for the 6,272, but this value is not the reprojected. Okay, we already know that NDVI value between -1 to +1, this number, but this is the high value because this image collection is not the reprojected. Okay, so now our challenges is that we reprojected this image collection, then we can get the proper result. Okay, and I will try to discuss about this, and I also give the short summary about this previous code. So here the first line of this code, I just import the MODIS NDVI MODIS 60 day 16 day composite global 250 meter data set. I simply import this data set, and then I will call my the large scale international boundary polygon shapefile. I simply call this data set. Then I filter my specific country Colombia. Then I simply select my specific band NDVI, and then I simply filter the date between this time frame I want to observe the NDVI. Then from this date I get from here the median. Okay, or average, you can get what you need, just you put here median, average or other, you can simply put here this statistical okay function, and then I can make here the a visualization parameter. Okay, in this parameter here you can see this mean pixel value, this image showing the mean pixel value, it will be start from the point 0. Okay, and max pixel value 8000. Okay, between this range 0 to 8000 this pixel image value will be short in this images. Okay, then we will use here the a list. In this list I will make here the different type of color. Okay, and after this I simply clip with my shape file. Okay, then I can get this result, this layer. Okay, so now our challenges is that this result is not the reprojected. Okay, so now I want to reprojected it, and I want to get this result from the -1 to +1, this pixel value. So how I can do this? So first of all I simply go to this image information sheet. Here you can see this is the our image collection, Modis image collection. I simply click to here. Here you can get all of this information about this data set. Okay, here you can see the bands description. I simply click on the bands. Here you can see the bands. This is the NDVI band. I work with this band, and this is the normalized difference vegetation index. Here you can see the mean and max pixel value already defined here, and also defined a scale. Okay, they define there is the scale. So now I want to do the scaled, this reprojected this scaled value. So for this I just multiply this scale number. I just multiply this scale number with the whole collection. Okay, here you can see I work with this whole collection is that filter NDVI. This filter NDVI, if you want to check how many images will be available here, I simply check it using the print function. Then I simply call this variable name filter NDVI. I copy it and paste here. Then I simply use here the size function. Okay, and after this I simply click on the run button. Here you can see how many images will be available here. You can see there are the 138 images will be available here between this time frame, but this image will not be reprojected. Okay, so now I want to reprojected it. So this is my whole collection, and this 138 satellite imagery will be stored this variable filter NDVI. Okay, so now I want to multiply this scale factor. Here you can see this is my scale factor. Okay, this is my scale factor. So now I want to multiply with this scale factor with this whole collection. There is a total 138 satellite imagery, and it will be stored under this variable filter NDVI. So now I want to just multiply with my scale factor 0.001. Here you can see 0.001 with my whole collection, then it will be reprojected. Then I can get this value between -1 to +1 for the all of this pixel value. So now I want to try to show you that how you can easily do this. Okay, so first of all I take a variable. From here. Suppose I gave this variable name is scaled NDVI. You can give the any variable name. I simply use here this variable name is scaled NDVI. Okay, you can use the any variable name, it's totally depend on you. Then here I use the two function. So first of all you can see here this is my whole collection. So this is my whole collection filter NDVI. Here included the total 138 satellite imagery for Modis NDVI, but this satellite imagery is not the reprojected. Okay, so now I want to reprojected it. So I simply call the filter NDVI. I simply copy this variable name and paste here. Okay, after this I make a function. This function will be multiply with this scale factor with this whole collection. Is the filter NDVI because it included the total 138 satellite imagery. Now I want to calculated the our scale factor with this whole collection. So I simply use here the map function. Okay, and I will discuss about the map. So map is a function. This function is the connected the whole collection with your function. Suppose I use here the map function, then I define a function here. I will write this function. So we and previous day I will discuss about the how you can easily define the function. So I simply use here the function. Okay, I define the function, then I define here the element name. Element is the image img. You can use the any variable name. Element is a variable name. I simply use here the img. Okay, image. Then I use here the curly bracket, and we already know that about the structure, about the function, how you can define this function. And between this curly bracket I defined here my argument, what I need. I want to multiply with my scale factor. So I simply use here the return. It will be returned and multiply this my image img. I simply call my image. It will be multiply it will be multiply with this scale factor. So what is my scale factor? I simply find my scale factor from the data information sheet. So here you can see this is my scale factor. I simply copy this scale factor and paste here. Okay, and then I simply use here the copy properties function. Copy properties and defined here my image. Then I simply use here my system time start and system time end. It means that it has a system. Here you can see, here I defined this system. This system time will be start from this time, year of 2015 1st January, and in time will be 2020 December 31. Okay, so now I simply use here the image. This is my element name which I defined here element, and now I define here the system time end and system time start. So I simply write the system time start, and then I simply use here the system time end. Okay, so here I define here the copy properties image, then I simply define here the system time start and system time end. Okay, so in this time I will again explain this code what I can do. So in this time I want to reproject it this scale value. Okay, so here the filter NDVI, this variable included the total 138 satellite imagery of MODIS NDVI, but this satellite imagery will not be reprojected. Okay, so now I want to reproject it. So just I simply multiply this whole collection. So this is my whole collection because it included the 138 satellite imagery. So I simply use here the function, and this the map function. So I create a function here. You can see this is my function, and in this function I just take the element, and after this curly bracket I define here the return image, and it will multiply with my scale factor. Okay, so now I connect this function. This is my function. Now this function I connect with my whole collection. So for this I use here the map function. Okay, so this is my function. In this function I defined here the whole collection. It will be multiplied with the scale factor, and now it will be connected with my whole collection. This connected work done by the map function. This is my map function. Okay, so map function is mainly map. This is the function. This map function is mainly used for the connection with the whole collection. Okay, when you make a function, this function will be connecting with your whole collection. Okay, so in this time I make a function, and this function will be connecting with my whole collection. This is the my filter NDVI, it connecting using the map function. Okay, so in this time, any doubt in here in this line of this code? Any doubt? Anyone have any doubt or any question? If you have any doubt or any question, then you can ask me. So it's the very easy. Here you can use here the I simply take a variable scale NDVI. After this filter NDVI, here included, this is my whole collection, because I want to take this the filter NDVI, and here I can get the total 138 satellite imagery, but this satellite imagery is not reprojected. Okay, so now I want to reprojected it, and so for this I simply use here the with the multiply with this whole collection with this scale factor 0.0001. Okay, then this is my function, and now I want to connect this function with my whole collection, so that's why I simply use here the map function. Okay, I hope you understand it. Okay, so now I will go to the next part. Here you can see, now I want to check how many satellite imagery will be available in the scaled NDVI. Okay, so I simply use here the print, and after this I simply use here the scale NDVI, simply copy it and paste here. After this I simply use here the size function. This size function determine how many satellite imagery will be available. Okay, we can get the same size image, you can see. Okay, so here you can see 138, but this 138 is not the reprojected, but in the this 138 satellite imagery will be reprojected scale value. Okay, so here you can get the two image. Now I want to work with this image because it will be reprojected, and I can get my the right value from the -1 to +1. So I simply work with this satellite imagery. So scale NDVI, I simply copy the scale NDVI and simply paste here. So I want to calculate the median, simply paste here, then mean NDVI. Okay, here you can get all of this. Okay, so now I simply click on the run. So what's the happened? Okay, we cannot get the totally white color map because we will not change our visualization parameter. Here you can see, this is our visualization parameter here. Here the minimum pixel value start from the 0.0 and maximum pixel value will be up to 8000, but we set here the -1 to +1 because I multiply with this scale factor. Now I simply just here the it will be -1, and then I define here the +1, then I can get the right result. Okay, simply click to the run. Okay, we can get this result, and in this time it will be reprojected scale value, and this scale value between the -1 to +1. Okay, I want to check it from the inspector tab. Simply click on the inspector tab and click on the any portion of the map. We can get this result. Then you can see this result is the 0.5. Okay, and now I also check it from here. You can see 0.35. Okay, so now this scale value is the reprojected, and we can get the right result. Our NDVI ratio -1 to +1, we can get this result from this number -1 to +1. So in this time I hope you understand this, and this is not for the NDVI. Suppose if you have a map for the land surface temperature, if you have made a map of the land surface temperature and this unit is the Kelvin, but you want to change this unit the degree Celsius, okay, then you need to just follow the same procedure. Okay, I will try to give you example. Suppose I work with the MODIS LST. I simply search this dataset. Here you can see different types of dataset will be available. Suppose I simply open this dataset. Okay, here you can see this is the Terra land surface temperature. You can see bands, and here you can see this is the unit for the Kelvin. Okay, but you want to make this map in the degree Celsius, then you need to follow the same function. Okay, you need to follow the same function, just change here what's the conversion of this the unit from the degree Celsius to the Kelvin, or Kelvin to degree Celsius. Just you put here the formula, then it will be okay. Okay, so this is the you can make the any unit or any conversion, you can easily do it using this map function. Okay, and now I will try to discuss about how you can export this satellite imagery. So I simply remove it. So here you can see this is my map for the NDVI map for the Colombia. So now I want to export this map as a TIFF format and work with this the ArcMap software. Okay, so I simply use when you export the any map, you just use this function export dot image to drive. Okay, I simply use here this function, and then I simply use here the parenthesis, and I simply press on the control and backspace in my keyboard. Here you can get all of this argument about this function. I just make a dictionary. For this I simply use here the curly bracket between two sides, and after this I simply curly bracket and put one by one keyword and key value. So first of all, image, this is my keyword, and I just put here the key value, and this key value is the which object you want to show your map. Just write this variable name. So in this time I want to show this map, this object, study area. Okay, I simply copy this study area and paste here, and after this description can be anything, is just a variable name. Okay, it will be anything. I simply used here the suppose modis ndvi. You can put any name in here. I simply modis ndvi Colombia. Okay, and folder is the specific folder of your Google Drive. Suppose I want to make this folder name is the 9th base. Okay, okay, so Google, when you find your Google Drive, you find a folder. This folder name is the 9 base. It automatically create in your Google Drive. Okay, then file name prefix is not needed for this time. I simply remove it. Dimension not needed. I simply remove it. Region is your shapefile variable name. So your shapefile variable name, here you find this shapefile variable name. Our shapefile variable name is the ROI, because this ROI stored this Colombia country boundary shapefile. Okay, I just simply copy this ROI and paste here. And scale is the resolution of your satellite imagery. So here I use the modis ndvi. So I want to check it, what is the resolution. Here you can simply use here, this resolution is a 250 meter. Okay, so I just simply put here the 250 meter resolution. So I simply put here the 250 meter resolution, and other not needed for this time. I simply remove. Then max pixel. So when you work with the big region, suppose you want to work with the big large country boundary shapefile, then you can just put here this value is 1E13. Okay, and it not needed. I simply remove all of these things. It not needed for this time. I simply remove, and I simply click on the run button. You can see our task tab will be running. Okay, you can see task tab will be running. I simply click on the task tab, and you can see modis ndvi Colombia. I simply click on the run, and every information is okay. Then I simply click on the run, and it will be automatically downloaded in our Google Drive. Okay, so it will be working. So here you can see when it will be completed, it just make the mark sign like this. Okay, so it will be working, and when it will be finished, then I will go to my Google Drive and try to show you this. Okay, so I hope in this time you understand all of this function, how you can easily reproject your scale value, and how you can easily export this map as a TIFF format. So if you have any question, you can ask me. Anyone, any question or any doubt?
Yes, please, max pixels in the exporting image.
Okay, so max pixel is a function. Max pixel is a function. So mainly we will use this max pixel function when we will work with the big region. Suppose this is the Colombia, this is the total country boundary shapefile of Colombia. So this is the big region. Sometime you can see when you want to export the tip images, you can get the some error, it will be not exported. Then you can just put here this value. So it is the large value 1e13, this is the large value of the max pixel. So when you work with the big region, just put this large value, I think it will be automatically downloaded and there is the no problem will be occurred. Or any question, anyone? Okay, so if you have any no question, then I will go to my today's training session. So it's just in this time I will try to show you that how you can easily reprojected the scale value, and yesterday we will completed all of this code. So that's why in this time I just show you that how you can easily reprojected the scale value. Okay, and also showing that how you can easily export this map and it will be working. So this is the large area, so this has the large configuration, so that it has take some time, and after when it completed I will try to show you that. Okay, so now I will go to my slide and try to discuss the today's session. Okay, so I open my slide.
Recording in progress.
So after 7 minutes this meeting will be end, and after this I will send you the Zoom link again, just join. Okay, so after 7 minutes it will be automatically end, and after this I will send you the Zoom link again. So I will start it. Okay, so today first content is that filtering and visualizing the satellite images in Google Earth Engine. It can be the different types of satellite images, just Landsat or Sentinel. So first of all I will try to discuss, and this is the same procedure for all of these satellite images, just something changed will be the image properties or satellite image properties, but all of the process is the same. Okay, so one of the most fundamental part of Google Earth Engine is selecting and filtering the image you need and display these images on the map. And Google has already selected a wide variety of public data set. We can easily use the public data set, just Landsat, Sentinel or other satellite images, and use it. Okay, so first of all, when you filter and what's the factor I want to filter, I will try to discuss about this. First of all, you want to filter a satellite images for a specific region or a specific area. You want to, this is the one factor. Suppose I want to need a satellite images for Landsat 8 satellite images, I want to need for the region of Dhaka city. So this is the one factor for filtering. I filtered the satellite images for my specific region. I want to need for only for this Dhaka city satellite images. Okay, so this is the one factor. Next factor can be that I want to only for those images which image will not be more than 1% cloud cover. Okay, so this is the another factor for filtering. I want to need only for those images which image will not be more than 1% cloud cover. Okay, so this is the another factor for the filtering. And finally, I want to only for a specific time period of the images. Suppose I want to only for the images year of 2017 or other any date what you need. Okay, so this is the total 3 factors when you filter any satellite imagery. It can be Landsat, or it can be Sentinel, or it can be MODIS, any satellite imagery. So first you need to selecting your area of interest. Okay, then you need to filter your image properties. What's the image properties? Image properties, suppose I want to need only for the image which image will not be more than 1% cloud cover. Okay, so this is the one properties. Okay, and then I want to only for the images year of 2017 or any other specific time frame what I need. Okay, so this is the common 3 factor. Okay, so now I will go to my code editor and explain one by one so that you can easily understand how you can easily filtering your satellite images, and after this how you can easily visualize the satellite images in Google Earth Engine. Okay, so I simply open my code editor. I take a new code editor. So first of all you can search the top of the code editor search bar. This is the search bar. I simply search here the Landsat 8 top of atmospheric satellite images. I simply search here the Landsat 8 TOA, it means the top of atmospheric. So I simply select this dataset Landsat 8 collection. Here you can get all of this information about this dataset. Here you can find this dataset availability date. Here you can see this dataset will be start from the year of 2013 and present date it will be present, and you can see this dataset provider is the USGS and Google. You can see the collection snippet, and next time I will try to show you that how you can use the collection snippet. Okay, and here you can see the description about this dataset. Okay, and here you can see that this is the bands. Here you can see the different types of band this dataset. Okay, also you can see this is the resolution of the every bands, wavelength. Okay, and this is the image properties. Okay, here you can see different type of image properties. From this image properties you can easily filter the any specific image properties, and we also try to show that how you can easily do this. Okay, so now I want to import these satellite images, so I simply click on the import. Then this satellite will be Landsat 8 satellite imagery will be imported in my code editor. Here the image collection, this is the default variable name. If you want you can change it or not, it totally depend on you, but in this time I gave this the short name. Suppose I can give this name is the L8. Okay, so L8 Landsat 8, I can change this name. So now I want to check how many satellite imagery will be available between this time frame in this in the whole world. How many satellite images will be available between this time frame year of 2013 to the present time. I want to check it, so I simply use here the print function. I simply use here the print function, then call here the L8. This is my whole collection is the L8, this variable. Actually this L8 it is the variable, and this variable stored the whole Landsat 8 collection. So I simply call the L8, then I simply use here the size function. Okay, size function, and then I simply click on the run. You can see it will be computing, and after this I can get a number, and this number define how many satellite imagery will be available for the whole world between this time frame year of 2013 to the present time. Okay, so now it will be computing, and we can get the large collection for the whole world. Okay, so it will be working, and after 1 minute this meeting will be end, and after this I will send you the Zoom link again, so please join. So here you can see we can get the more than 1 million satellite imagery will be available. Okay, so it is the largely collection. Okay, so now we have to filter it somehow. So now I want to filter it somehow. Suppose this is the whole collection, but I want to need only for the specific region, for the Dhaka city or other region what you need. So first of all I filter it for my specific region of Dhaka city. Okay, so just I imported here the shape file of Dhaka city, then I will work with this. Okay, so thank you for watching this video, and if you want you can join with our the full beginners courses. So for this you need to just registration, and this course and our this the running for the 9th batch, and after this our 10th batch will be start as soon as possible. I will give you all of this information in the video description, so just you can read this video description and contact with me for if you want to join with our the 10 best training session. Okay, so thank you for joining with us, and also join our the online training classes. Okay, so thank you all.